Hey everyone, we're going to look at a question new to Math 120 from Chapter 6, and that is the volume of a box. So we're going to start by reading the question. It says that a box has a volume of 30 cubic feet. Its height is 5 feet more than its length. Its width is 3 feet less than its length. Find the three dimensions of the box. So this translation part, that first part making the English into mathematics, notice I've just copied and pasted each of those sentences, beginning with a box has a volume of 30 cubic feet. So we're going to translate that using exactly what you'd expect, a V for the volume and equal to 30. We'll handle the units later. The formula will give us that cubic units when we multiply things together. The second sentence says its height is 5 feet more than its length. Now that more clearly means addition. More than swaps the order. If you want to be really literal, you can write this as L plus 5, swapping that order of addition. This is a Chapter 1 topic when we were talking about translating from English into mathematics. Of course, the height is going to give us H equals. This becomes H equals L plus 5. Now that really matters in the next sentence because that less than is talking about subtraction. Subtraction is not commutative, which of course means that the order that we subtract in matters. So when we see a less than statement, and if any of you are doing tax forms, you see a lot of them this time of year, the length that we hear about second actually comes first. The 3 that you hear about first actually comes second. And of course, its width is translates as W equals. So that's going to result in that swap subtraction giving us L minus 3 for W. Now the formula for the volume of a box is exactly what you'd think. It's the one dimension higher than the formula for the area of a rectangle. So that volume, V, is going to be equal to all three of those dimensions multiplied together. Length times width times height. Now, just like with an area of a rectangle question, we're now going to substitute in what we know. So I'm going to recopy the formula, V equals L times W times H, but I'm going to substitute as I go. So instead of writing V, I'm going to write what it's equal to, namely 30. And of course that L is going to say an L, the W is going to become what it's equal to, L minus 3, and the H is going to become what it's equal to, L plus 5. So that substitution taking place, the parentheses is grouping symbols reminding us that that L plus 3, for example, is W. It needs to be done first. Now, this would be great. If you looked at the right side, you'd think it's factored, it's already set, but you look at the left side, you see that 30, and you think, oh my golly gosh, we're going to have to use the zero factor property to solve this, and that's not 0. Of course, that's 30. So a lot of work is going to take place just to get the 0 and the zero factor property, and that's not terribly surprising. The 0 is, in some sense, the most important part. It's a very powerful number. So we're going to have to subtract 30 from both sides to get the 0. But then you look back at the right side and you see that there's all those parentheses. There's all that multiplication that needs to happen. So before we even subtract the 30, we're going to have to do that multiplication. We're going to have to expand the right side. Now, multiplication is associative and commutative, so I chose to multiply the two binomials together first, L minus 3 times L plus 5. So I foiled those, first outer, inner, last. So L times L, of course, L squared. L times positive 5 is 5L. L times negative 3 is negative 3L. And of course, a positive times a negative, that 3 times 5 gives us negative 15. Notice the middle two terms, the 5L and the negative 3L, are counting the same quantity, so we can combine them. Looks like the positive will win by 2. Now, I'm going to do two things in the next step, because remember the goal was to get that 0 all along. So I'm going to subtract 30. I'm also going to distribute to clean up the rest of those parentheses on the right side. So that's going to add another factor of L to each of those three terms. So that L is going to get multiplied into the L squared, the 2L, and the negative 15. So when we subtract 30, we distribute. We've got the 0 and the zero factor property. Now we're changing gears from getting zeros to factoring. So we're looking at that right side. We see 4 terms. 4 is an even number of terms, so we're going to factor by grouping. That doesn't always work, but the way I've written these questions and coded them for your homework, it will. So I'm looking at the first pair, and I see that there's an L squared in common, just in that first pair. You don't have to use parentheses here in class. I just drew a vertical line. That's fine too. And I see an L squared in common. Notice that in the second pair, if you want to be very formal, you can see there's a negative 15 in common, which of course will leave an L plus 2 behind. So when we factor out the L squared from the first pair of terms, we get an L plus 2 left behind. If we kind of cheat and say an L plus 2 has to be left behind in the second pair, then we can see that a negative 15 is factored out. It's good to check that negative 15 times positive 2 is negative 30. Now, that's not yet factored. Bits of it are, right? The first pair and the second pair are kind of made into factors now. But there's that subtraction out of bounds, not inside of parentheses. This is actually a difference on the right side. Expressions are characterized by the last operation you perform in the order of operations. So we still need to factor the right side, and that's easy enough. The L plus 2 will come out, and left behind will be the L squared minus 15. So what have we done? We translated the sentences, we wrote the formula, we substituted in what we knew, and then we said we need a 0, which said a lot of expansion on the right side, finally getting the 0. Then we started factoring that using the factoring by grouping, the fact that there's 2 pairs of 2. We've got an L plus 2 now, so after getting the 0, after factoring, we use the property, which asks the question, when is L plus 2 equal to 0? Well, it's equal to 0 when L equals negative 2, and I've already struck that out because this is a geometry question, and length can't be negative. So we cross it out. There's still 2 more, so let's see if we get a positive. L squared minus 15, we're going to use the property on it, ask when it is equal to 0. It's certainly equal to 0 when L squared equals 15. I'm going to be very formal with this. I'm going to remind you of the square root property. I'm going to remind you of the plus or minus sign. You won't have to show this doing your work. If you skip over this next step where you've got that plus or minus sign there for geometry questions, that's fine with me. But remember that plus or minus sign is there when you've got even powers. Now, of course, we're going to do the same thing to the negative we did to the L equals negative 2. We're going to throw it out, and we're going to be left with L equals the square root of 15. Now I got my calculator out, and according to my calculator, that's 3.8730 feet. I rounded to the nearest 10th, 100th, 1000th, 10,000th place there. That's why it's a 0. I've also got the units. So with that number in my calculator, I went back up to the original statement of the definition for H and W. So here's our H. Our H is L plus 5, so the square root of 15 plus 5. Out comes the calculator again. Actually, we're just adding 5 to the ones place. And we've got 8.8730 feet. Same thing for the width. It's 3 less, so we take that square root of 15 and subtract 3. Well, that just gets rid of the 3 in the ones place. Now, that's all very well and good. We've got our 3 dimensions complete with units, but we do need to check. So this is a job for a calculator. I put this in. I put in the rounded form if you kept it exact, and a calculator is perfect for that. You'll get really close to 30. And notice I got really close to 30 as well, 30.0008. So I've stated our answer, and we've done a new question that you can expect on exams and quizzes. And hope that helped, and hope you're doing well. Keep in touch. Have a good one. Bye.